Hello students, let us start with the next module of this chapter, matrices. Here we are going to learn some basic elementary transformations. Now the first question is, what is elementary transformation? We have already studied this in determinants. So let us try to understand this once again. Elementary transformation are 6 basic operations which are dependent on rows and columns. Here 3 are due to row and 3 are due to column. So let us try to understand the first elementary transformation. Let us take an example here. The example is as follows. I have a matrix A. The elements are as follows 1, 2, 3 and 4. The operation which I am performing here is R1 interchanged with R2. So here what I want to do is I want to interchange the elements of the rows. So this was the matrix which we have. And as I applied this operation, that is R1 interchanged with R2, the elements get swapped. That means now R2, previous R2 is now the R1. So this is the value of the transformed matrix. So I denote it as A is similar to 3, 4, 1, 2. And this matrix is now called as the transformed matrix. Here what we should note is, we cannot compare the transformed and original matrix. That is, the transformed and original matrix cannot be actually compared because the matrices are not yet evaluated. So here what we observe is, symbolically we can write as follows. Ri is interchanged with Rj, or I can simply denote it as Rij, means the element of ith row is interchanged with the elements of jth row. Interchange of any two rows. Here the name itself suggests that it is due to row transformation. So I can denote it as, here we interchange the ith row and jth row, getting a transformed matrix. Let us try to understand the next here. The second example, the second transformation can be understood with the help of this example here. Again we are taking the same matrix which was 1, 2, 3, 4. But now the transformation which I am applying here is C1 interchanged with C2. So the matrix which we have is this one. As I interchange the columns, the elements get swapped. Now the new matrix is 2, 1, 4, 3. So I can denote it as A is similar to 2, 1, 4, 3. This is the transformed matrix. Symbolically, I can write it as Ci is interchanged with Cj, or I can simply denote it as Cij. Here, the interchange of any two columns, in the name itself, we can make out that it is nothing but it is due to columns. Here we interchange the ith and jth column and getting a transformed matrix. Now let us try to understand some important point here. What we should note here is, a row of a matrix cannot be interchanged with a column. That is, Ri interchanged with Cj is not applicable. We can only use Ri interchanged with Rj. Similarly, column cannot be interchanged with row. That means Ci cannot be interchanged with Rj. That is, we can only use Ci interchanged with Cj. Thank you.